Our method builds a representation for dynamic scenes from a single monocular input video like the one shown here, which exhibits challenging motion and scene structures. With this representation, we are able to render novel views and times. This lets us, for example, freeze time and move the camera, freeze the camera and move time, or a combination of the two. Our method only requires a single view and can therefore be used on natural videos collected in the wild, as long as camera pose can be extracted, for example using classical structure for motion techniques. Here we show some results on a variety of challenging sequences. While our method does not explicitly compute depth maps, we can visualize the expected termination depth of each ray, which gives us some indication as to the reconstructed scene geometry, shown here. Our method consists of two scene representations, one dynamic, one static. We train these such that when rendered together with a learned blending weight, the output should match the ground truth views. Here we show each representation rendered separately, on top, and the combined result on the bottom. In order to render novel times, we warp the reconstructed scene from input frame indices. Here we show 2 frames and the interpolated frame at the bottom. And this is a visualization of our plane sweep render process, where the entire scene is accumulated in a buffer in a front-to-back fashion. Here we compare our scene flow warping based approach to the naive solution of simply evaluating the space-time representation at fractional time indices. And here we show some visualizations of our reconstructed scene flow in 3D. Here we compare our method to recent approaches for monocular video or single image view synthesis. Most prior work relies on constructing a consistent depth map per frame and projecting it into new views. These approaches have difficulties at regions with fine geometry and disocclusions. NeRF works well in static regions, but cannot model scene dynamics. Our method can also open the door to other applications, for example, 3D video stabilization, where our scene flow-based framework has the advantage over traditional 2D video stabilization in that it does not require cropping or image warping. We can also create motion sculpture visualizations in 3D.